Were you going to present the slides?
I'm not sure Alvaro's actually here. He's listed as Zulip only at the moment.
Okay. Well,
And
it's
for
the. Go ahead. It's at the top of the hour. Shall we wait a few more minutes?
if we could, we're still missing some of the actual presenters. Just working through the list.
We don't have Prakash. I do see Zen Tan
Yep, he's already confirmed.
and Hang Shi. I don't see Hang Shi. Yes, I do. Hang, could you confirm your mic? Try to say hello. Gare says he'll be momentarily. He's got connectivity issues, so I think we ought to give it a couple moments.
Okay, I'm messaging Hangshi. Okay, no response. And last of the, actually, two more sets of presenters we haven't heard from. Xin Yi, could you please test your microphone?
Hello.
Hi, we can hear you. You're slightly faint though.
Hello. I can hear
much,
you.
That is much better now. Thank you.
Thank you for increasing your mic.
Okay, thank you.
Did we get to Ran Chen?
Do we see him yet?
Not yet.
Okay, so we're short Ran Chen.
Looks like Kair is in. Can you test your mic, Kair?
One more time. Good morning, folks.
Good morning.
We can hear you. So Hangshi is the last person that we haven't heard from.
We'll probably give it 3 more minutes and go ahead and start. We have about an 80-minute discussion and about 2 hours. So we have time for discussion on each point.
Okay, we saw that Hangshi was trying the test mic. Give Hangshi one moment. Hangshi is offline and restarting, looks like. And this is why we do all this up front.
So as long as we're doing this, can you hear me?
You are loud and clear.
Great. Thanks.
Wonderful, Alvaro.
Okay, once we've heard from Hangshi, we can begin, Zoo, I think. We still do not see Ron Chen in here, though.
No, we do not.
Hangshi, we heard an open microphone, and we now hear you.
Okay, good.
Thank you. We're glad. Thank you for all our presenters for speaking into the mic. This is a note. Well, hopefully all of you have seen it. If not, this is a reminder that the IETF policies are in effect, such as patent or code of conduct. This note is just to point you in the right direction. Reminder, if you're participating, you agree to follow the IETF process and policies. If you're aware of any contribution that's covered by patent or application, you must disclose that fact or not participate in the discussion. And as a participant in ITF activities, you acknowledge that any written audio, video, or photographic records of the meeting will be made public. And personal information you give to ITF is handled as accordance to the ITF privacy policy. And we agree to work with one another. Please, if you've not seen this, read it once, because we have a little extra time. I've actually gone through it instead of say, see your note well. Our agenda is meant to cover presentations that didn't make it to ITF once in time slot. You can get the materials there. You're on the Meet Echo. I'm sure that G and your chairs would love it if you help with any note taking, especially if you're a presenter. Please make sure we've got any comments you want to make sure are there. Our agenda is ahead. We'll start with Anchor. We're going to go with first adjustments to standard BGP timers, then one administrative domain, flow spec drafts, BGPLS draft, and constrained RT drafts. So with that, we're going to hand off the presentation to Anchor. So you can have you grabbed the slides before Anchor and been able to pick them out? I'll pull up the slides and then you'll have control. Up, looks like you've got a deck.
Okay, how do I grab it?
Okay, you can grab it. I can grab it for you if you want and then pass control.
I'm not sure how to grab it. I'm sorry.
Okay, I will get the slides and come back. Just a minute.
Okay.
Let me know if I've got, well, hopefully I've got the latest one here.
There's only one version there, I think.
Okay, go ahead and you should have control of the slides. Let me double check for you. Okay, I've passed control to the slides for you. Let me know if you have trouble controlling it.
All right. Okay. Thank you, Sue. Good morning for folks on the East Coast in the US, and good afternoon for folks in Europe, and good evening for folks in India, China, and other Asian countries. All right. So this the topic is applying TCP user timeout parameters to BGP sessions. Presenting on behalf of myself and the co-author Robert Razuk. All right, just click on the next page. It's not moving. I think I'm not familiar with this. It seems. Okay, this is good. Okay, looks like there's a delay. Okay, let's let me start with by talking about what this TCP user timeout is. It's actually it's a very basically old concept. It's actually defined in the BGP in the TCP base spec IFC 0793, and also with the latest updated IFC 9293. It basically says you with this timeout, you basically the TCP connection should be terminated if it's not progressing within this specified timeout duration. So the interim is, if you look at, let's, I think what is particularly relevant is about the delivery of application data by TCP. They are really two different types and concepts. One is basically the transmitted data. It's basically the data has been transmitted by the local TCP and it's waiting for acknowledgement. And the second one is buffer data. Basically, the data has not been transmitted. It's waiting to be transmitted because the remote side has advertised a zero size window, TCP window. So locally we cannot send anything. Although there's a slight confusion, I think in some of the document that reference this TCP user time, it's basically it didn't really code out the second part. But as far as the application is concerned, there's no difference between these two cases. Its application data is not delivered within a certain period of time. There's no difference at all. All right. So this the user timeout would apply equally in both cases, as far as the application is concerned. All right. So there's at least one implementation that I'm aware of, and for other implementations, basically I'm not. Basically, I have not done the research. I have not asked people around about other implementation. But there's a Linux implementation. This is just an example, and so it's basically, if you look at it, the implementation introduced a TCP socket option called the TCP ASCO user ASCO timeout. So basically, application can simply call this SafeSock option to enable this. The timeout value is specified in milliseconds. And also, if you want to basically retrieve the timeout value, you can do a getSock option using the same TCP user time options. What it does if basically for the two cases that show in the previous slide, if either of these, in either case, if the data is user application data is not delivered within the specified timeout value, it basically will return timeout, the error to the application in the TCP the read or in the socket read or write operation. It's just like any other socket errors, like if the remote side close the socket, the application locally would receive ePipe. So there are a number of errors that the application has to deal with. This would be a new addition with this socket option. There has been basically a couple of bug fixes to the implementation, which I actually basically fixed them myself, and was committed around January of 2021. It has been actually more than 2 years ago, and it's shipped in Linux distribution 5.4. I don't remember the minor version there, and there are 2 of them. These are the hashtags. For the other applications, for the other basically TCP/IP stack, basically, if let's say currently, if it does not have an implementation, I would think the implementation actually it should be straightforward, because this is just we are talking about the implementation of timeouts. It's basically there are typically 3 operations. You start the timer, you basically reset the timer, or you do the measurements. It really does not require any optimization or complexity. It's straightforward. There's no magic there. All right. So as far as BEP is concerned, so there's this concept. I think folks call it the stack sessions for BGP. It basically simply means that BGP messages are not delivered for extended period of time. This can result in stale routes in the routing system, and so it's reasonable and desirable to have a mechanism to detect these situations and also terminate the session. I mean, currently, I think the problem is mostly speculation due to the lack of automated detection mechanisms in the implementation, in BGP implementation today. but this can happen. So this is, if you look at, if that's a problem definition, then TCP user timer option, it's actually very good fit, because it's specifically defined for this type data delivery issues. And if this is with this option, the detection and it's much more deterministic and precise. It's basically, it can do a much better job than BGP itself, because for most of the implementation, I'm aware of, the BGP itself actually does not have that much visibility into the TCP state, whether it's in retransmission mode or how long it has been. It's simply does not know. And with this TCP option, it will require minimum code changes in BGP. Excuse me. So as a spell out in the spec, basically we have made several recommendations. Of course, we recommend using this TCP user timeout option, and the default timeout value in the draft is basically, as the current specifies, 5 times the whole timer, but not less than 10 minutes. And obviously, this should be configurable. And another point is that basically, because when the BGP comes up, depends on the number of sessions, amount of data that need to be exchanged. It can be quite heavy computation-wise. So we basically recommend that you enable this option only after UR is received from all the neighbors, or 30 minutes post the session establishment. And to mitigate some of the possible false positives, basically we say you follow the GR procedures for this E timeout, this error, and log the event, and because this is the most likely attributable to the implementation of the remote device. You work with the peer, alert the peer administrator, and work with them basically to for its resolution. And the next slide, obviously, your feedback is welcome, and we also would like to request the working group adoption. That completes my presentation. So do we take questions right now or wait at the end?
Questions right now.
Okay. Yeah. If you have any questions, please feel free to ask right now. Question or comments?
Hi, Ben, the other proposal for this. I'm curious on how you came to 30 minutes on your, if you go back a couple of slides.
These timers, I think several of them, obviously they should be configurable. It's just, I think as a common practice for most of the timer related values, and most of the time we recommend default. So that's 30 minutes feels like it's long enough for the routing to converge after basically the BGP comes up. But if your particular configuration basically requires a longer time, you definitely should configure that way. So these are not basically hard coded. These should be configurable.
Okay, I'm more interested.
On the other hand, if basically your environment is really a small scale, you probably want to reduce that, because if it takes 1 minute for everything to converge, then 30 minutes would seem to be a very long time. As we all know, BGP is used basically from the small to medium to very large scale. So there are lots of configurable parameters. This would be one of the these several time-armed values would belong to that category.
Go ahead, Randy. You had comments?
So let me make sure I understand, Enke. Essentially, what you're saying is TCP provides this. Don't further complicate BGP. Question mark.
Yes, Randy, that's pretty much the message. There's already existing a very nice, mechanism for doing that. And the TCP can do a much better job than BGP because the TCP is the transport for us, right? For BGP, it actually certainly has all the information, necessary information to deal with it.
Sounds good to me.
Thank you.
Any other comments, questions?
You see, I was amazed actually. The TCP was developed at least 30 years ago, and actually the folks actually had a vision about this kind of problem, and they actually introduced a mechanism for it. That is quite amazing. It's another addition to all the amazing work that has basically put into the TCP.
Go ahead.
That's a comment. That's it for me.
Yeah, so apologies if I'm difficult to understand. So Enke, for cases where TCP is misbehaving, and that includes like firewalls, this has good value, I agree. But I don't think it's the core use case that's necessarily applicable. I think the second presentation will get into some of those details, but I think this problem space that's being discussed has two partitions. One place where TCP itself is misbehaving, which this addresses, and other cases where TCP is properly behaving, but the application is not properly behaving. I see that right?
Jeff, I'm just thinking that, although in the spec, in the draft, I sort of list the example where this could happen. I feel like it's more like a handcrafted scenarios, and this it's very hard for me to actually even imagine this kind of problem would occur without having a bug in BGP implementation, because if you look at it, the BGP has its own keep live timer. It also has its own hold timer. The hold timer definitely should have kick in. It's hard to imagine the remote side actually keeps receiving TCP. No, keep sending TCP, BGP keep live, but not reading the BGP keep live and still keeps the sessions up running. And the whole timer does not kick in. I would think this really falls into very, very corner cases of some kind of either crafted scenarios in the lab or some nasty implementation bugs in BGP. This type of issue, right? It's very hard to imagine it's actually a TCP issue.
Yeah, so I'll offer my commentary that for my 20-odd years worth of working on BGP, I've run into at least 3 implementations that have no issues with TCP, and it's strictly the TCP read applications in the BGP stack that's the problem. So we have different experiences. Again, this has value, but I don't think it's the total solution. That's my comments. Thank you.
Yeah, I mean, we look at today, okay, the network in internet in general, it works well actually. It's because the BGP has its own keep live as well as the whole timer. They would kick in. They should, right? For some corner cases, for some mysterious reasons, or hardcore crafted scenarios, somehow the whole timer basically didn't kick in. All right. Yeah, I don't have any further comments. Thank you.
Randy, did you have a comment? And then we're going to
I'll be brief.
go on to the second presentation.
I'll be brief. It seems to
Mhm.
me that if you're having broken TCP, you fix TCP, you don't kludge further up the stack. You keep kludging, and entropy is death of the universe in the long run.
Am I pressing the right button? And I have control. I can hear myself echo, so this is really me to echo, echo, echo. So if I start rambling incoherently, I lost my train of thought because I hear myself with a 2-second delay.
Okay, that's fun. Can you get to the slides? Can you
Yep.
control them? Okay, good.
All right, thank you so much for spending some time on considering send hold timer. We've been kicking this document around for more than 2 years now, and I'm excited to discuss it with this group. The problem we are trying to attack is that in the wild we've seen scenarios where BGP speakers that are not under the control of the operator. So speaking from my own perspective, this could be my customers or my peering partners, where devices like that advertise a TCP receive window of 0 for a long period of time. And this can show up on certain implementations as, hey, slow peer is detected, or an out queue that never ever again decreases. And the curious thing is that because the remote system that has some kind of issue is signaling to us, I don't have any room for new information, we cannot send them a keep alive message. Now, under normal circumstances, we would expect the remote system to disconnect us because they haven't received our keep alives for some time. But we're dealing with systems that are misbehaving for one reason or another. And many implementations do not disconnect from such a broken situation. Indeed, there are keep alives, but they are sort of an asymmetric thing. In the current specifications, it's not clear that both parties should verify whether they can send the keep alive messages within the whole timer period, in addition to confirming they have received them. Next slide. So the consequences of this can be quite nasty. As I mentioned, this are scenarios that happen for hours on end, and the internet churns significantly over the span of a few hours. So I think there's 3 aspects to this. The inability to deliver BGP messages to the remote site means that the remote site is not aware of our latest updates and withdrawals, which might mean that the remote site is sending us packets for which we have no route. And we did queue up a message for the remote peer that we withdraw the route. It also means that if the session is not killed at some point, the likeliness of us having routes pointing towards the broken peer are outdated, because I don't think it's reasonable to assume that a remote peer that is no longer progressing BGP messages only has issues with that one specific session, but more likely has issues in all directions. And failure to disconnect from such a stuck peer also hinders our ability to inform the rest of the network that routes no longer exist. So how this manifests in internet forwarding is black holing or routing loops, and that's not great. So we've had, I'd say, two large discussions over the last 2 years. And my takeaway, but this is just my summary, and I'm happy to stand corrected if people feel that I did not characterize it correctly. Some argued that the changes to the finite state machine, the so-called surgery, was incomplete, that it didn't fully describe how the FSM should be described. And then others said, what you're trying to do here is way too invasive and makes the FSM unreadable or even harder to interpret. So I classify that as criticism of the internet draft contents, because we can address this by not explicitly updating the FSM, but by describing the desired outcomes. And then other criticism was more targeted towards the concept that it doesn't solve all cases of brokenness, or it doesn't do so within the promised amount of time. But by and large, I think there were some people that indicated it might solve some problems. Actionable suggestions that followed from these discussions, I think the general consensus was that send hold timer should be generous in the sense that we don't unnecessarily love connections where systems are just churning through the data, and as a transient state signals, please hold on sending me more. And from the get-go, we have agreed with that principle, because the send hold timer really is a backstop of last resort. It's like the last thing you should do in problematic situations. It should not be something that fires off because we set things too tight. Other suggestions were to change the tone of voice of the internet draft to be a little bit less alarmist, because when we originally discovered this issue, I personally considered it more of a vulnerability than as a simple shortcoming in some implementations. And it would also maybe be helpful to document what send hold timer doesn't solve. Implementation status. There are 3 implementations: OpenBGPD, FRR routing, and NeoBGP. 2 of the 3 are open source and can be inspected, and 1 is a proprietary implementation written by Dan Cox. To zoom in a little bit on the OpenBGPD behavior, the send hold timer timeline, so to speak, it starts when the remote system somehow has filled up its buffers to the point where it starts signaling, hey, my receive window is 0. In addition to that, the local system's outbound write buffer also should fill up. And depending on the implementation, this could be anywhere between 64 kilobytes or something larger. So this means that the remote peer is not accepting our messages, but depending on how large the buffer is, a small or a large number of BGP messages has to be generated and sent to the remote peer. And if the local system's outbound buffer has filled up, then the timer starts in OpenBGPD caused by the socket being unwritable. And once that timer expires, so that's 8 minutes from the top of my head, then it proceeds with the disconnection of the remote peer and basically does the same thing you would do if hold timer expired. So end to end, it takes more than 8 minutes, even though send hold timer is set to be 8 minutes. Now, I don't consider this an issue because, as I mentioned before, this is a mechanism that should kick in really pathological situations that don't seem to resolve themselves in some other way. Well, that's what I just mentioned. All right. So my hopes for a continuation of this work is that it is adopted as a working group document, that we gain more implementation experience, because not all BGP implementations operate the same way that OpenBGPD does or FRR routing does. So I think it would be very informative to hear from other implementations how they achieve a similar effect, and perhaps we can use that to improve the documentation. And it would be useful to get an INR registration for send hold timer expired in the BGP error code subregistry of the BGP parameters registry, so that in local monitoring there is an event code similar to say send to hold timer expired. These are some links I really recommend the working group to take a look at. There is the BGP 0 window test that is a simple Go program that you can connect to your own BGP implementation to inspect how your BGP implementation behaves if receive window 0 is advertised for a prolonged time. This is the program we've used to test whether the OpenBGPD changes were having an effect or not. And the BGP 0 window test emulates behavior I have seen in the wild. So it's not intended as a contrived test case. This I think is a very accurate representation of what BGP implementations might interface with in the wild. Ben wrote a beautiful blog post where he hunts down stock routes where the TCP0 window is suspect, so that might be informative. And then of course there's a link to the internet draft itself. And this brings me to the end of my slides, and I love to hear feedback from the room, for chairs and other implementers.
Go ahead, Enki. You can ask your questions direct to Job. Anchor, you can go ahead and ask your questions. I'm not seeing you in.
Oh, Kai, are you able to hear me?
Yep.
Hello?
Yes.
Yeah, okay, thank you.
you.
My concern with this approach, I think it's also a concern shared by, I think, several people on the mailing list. It's basically to solve the subset of the problem. As the job listed the conditions, there's several other conditions. One of the big if is basically the local TCP buffer is full. And only then this market would kick in. And that's a very, if we consider this problem as a serious, that's a very big assumption. because the local TCP buffer may not be full, but there's a important BGP update message in the TCP buffer that will be stuck there for a long time, and this MAC will not be able to detect that scenario, and the basically damage will continue to occur. So I consider this solution as incomplete, and it's a subset of the problem that's addressed by the TCP, this user time option. I don't think this draft, this proposal is actually necessary or even useful because it's incomplete. It does not solve a very important, BGP update message stuck in the TCP buffer.
Yeah, so can I react to that?
Yes, please.
Discussion.
So I'm not sure whether it's helpful to view our two drafts as competing for the exact same solution space. I think they do slightly different things and operate at different layers, each offering an advantage. The cases we observed in the wild were of machines that somehow were able to keep generating keep alives and send those. Each keep alive accompanied with the signal that the TCP received window is 0. So there could not be replies, but of course keep alives are not a conversation where you reply to each other. It's two unidirectional streams of information. And my feeling is that the send hold timer operates at an application level and offers some value in the case where the remote peer has a fully functional TCP stack, but something else is broken. And I think your proposal is advantageous in the case that there's an issue on the transport layer. So I don't perceive the two as mutually exclusive.
If you go back to the slides where you list at this condition it would work, all these conditions in that situation, and actually the TCP user time option would solve the problem. So I'm not questioning the problem statement. Actually, that part is fine. It's just a solution. I think here what this proposal does is a partial solution. And if we do the TCP user time or whatever problem you're trying to solve here is already solved by the TCP and in much more deterministic manner.
Okay, Anchor, we're gonna and Job, we're gonna go on to John and Claudio so they have a chance to make their comments. Folks, we're gonna continue this for about 4 to 5 more minutes. So John, go ahead. Thank you, Enki.
Okay, I'll be brief. I just wanted to add a little color to Job's. Okay, I'm actually going to put this into text because I'm getting horrible echo and I can't talk.
Well, John types.
Correct.
Claudio, do you want to go ahead? Claudia, why don't you go ahead and while John types?
I try. Can you hear me?
Yes, I can hear you. Please go ahead.
So I wanted to say I don't agree with Enke that the TCP user timer is covering more than the send hold timer. It's actually the other way around, because the TCP 0 window is not the only way of triggering this issue, because the 0 window only happens when the receive side buffer on the TCP level fills up and cannot progress anymore. But if the remote system is actually emptying the TCP's buffer all the time, but is actually not making any progress on that level, then we would still have.
We lost the end of that statement, Claudio. Can you try your mic again?
I sent
did-
Claudio a text message that he dropped off.
Alvaro, did you have a comment? Your mic is on.
Sorry, no, I didn't have a comment.
Claudio's trying to reconnect.
Okay, John, did you want to try with Echo, or you want to give up on it?
I can try one more time. Nope, still terrible echo. Gonna keep typing.
Okay, we'll pick that up in a few minutes. I think if we can, we'll take a break later on, but we're going to go on with the next presentation, and I'll try to cycle back for comments after Pradosh. Pradosh, we're going to pick up you. Job, thank you. I'm going to try to give us another time slot for comments later on. Okay, let me pick up the next person. Prakash, if you'll be ready, I'll bring the slides
So that's
up.
actually going to be me, not Pradosh. He's on the.
Oh,
he's
good.
He's
Wonderful. That's great. Let me go ahead and make sure check and see if it's the wrong deck. We'll pick it up.
Nope, this is the right deck.
Oh, wonderful. Just let me give you control. They're yours, Alvaro. Thank you.
Yep, thank you, Sue. And I want to start by thanking everyone who has already looked at this draft and who provided feedback and questions and comments. They have been very useful in us, the authors. We get together every other week to have discussions about this, to make the text better, and also, I think, to show interest in this topic. So thank you. Thank you for that. We had, in case you missed the emails on the list, we had posted the version 0 of this right before the IETF meeting in Japan. There were some comments and a lot of good feedback there, as I said. And we posted 0.1 on Friday. I'm going to say up front, we didn't address all the comments because we ran out of time, but we wanted to post something at least to show some progress for this talk. I have, at the end of the slides, we put a to-do list of the outstanding items. So please, when you get there, take a look at that. Make sure that if you brought up an issue, it's there. And if not, maybe we already addressed it. The slides are going to talk about what the current state of the draft is. So some of the comments that you already made may not be addressed here already. So what is the problem that we're looking at? I wouldn't really characterize it as a problem per se, but the situation that we have. There are many networks, operator networks or big enterprise networks, where the administrative domain, the entity who administers the network, has multiple ASs. This can be for many, many reasons. It can be the network grew this way. It can be there were mergers, acquisitions, partnerships, other relationships, where the span of control of an administrator really goes across multiple autonomous systems. Now, we see this all the time in documents from IDR, but also other working groups, where they talk about a single administrative domain, and where people say, okay, the intent of this is to propagate only through a single administrative domain, which is basically the definition that I talked about before, where a common administrative entity, say an operator or just a network operator itself, has control over multiple ASs. We're calling that not a single administrative domain. We're calling it one administrative domain, OAD. So that's where the OAD name of the draft comes by. And of course, the point of all this is that there is a desire to do better policy control and influence route selection across AS boundaries using attributes that would normally not go across AS boundaries. So that's why that disclaimer goes into a bunch of drafts. We want this to be across a single or a OAD, the one administrative domain that we're talking about here. So this slide basically summarizes what we're doing with the draft. We already have eBGP and iBGP sessions. We're defining in this draft a new type that we called eBGP OAD. The naming is, we did this intentionally because the idea is for the session to behave as an eBGP session, but because it is part of this OAD across multiple ASs, with the optional ability to have, to be able to do exchange of attributes that would normally not go across eBGP sessions, or that wouldn't be used in the receiving side of the eBGP session. So a simple example is local preference. The ROC says you shouldn't send it. If you receive it, you should ignore it. So in this case, for the eBGP OAD session, we're saying it is optional for you to send it. And if you're the receiver on the other side, you should receive it and use it. Because again, we're extending that domain across what used to be eBGP sessions. Again, default behavior is eBGP plus the option controlled by policy to send other things across. Currently, the way it is defined in the draft is this is controlled by configuration. I know, Jeff, you had made the comment about a capability that is on our to-do list to think a little bit more about this and consider that. So as I said before, this is what draft 01 still says. We want to follow eBGP rules. So attributes like the AS path, for example, would go would be forwarded or would be transmitted the same way they are in eBGP. So the AS path we would prepend the AS, right? So just like normal eBGP. And again, in addition, optionally, some iBGP stuff or non-transitive attributes. The draft talks about we have added more of the attributes to the list. That was a big comment that we got from 00. We had started with what we thought were some of the exceptions, but now we have added almost all the attributes are discussed there. There are some, for example, that we still don't want to go across the eBGP OAD session, like originator ID and cluster list. And the reason here is simple. We don't think route reflection should span across these types of sessions as well. So again, this is the crux of what the draft says. It would be great when you go and read it to make sure that what I just said in the slides is what is actually written in the text there. We think it is, but just to make sure. The other thing that the draft talks about, and this goes back to the point about the capability that I made before and Jeff's comment, is that currently the draft talks about the ability to configure this behavior on not just a session by session basis, but on a peer by peer basis unidirectionally. Meaning that we believe right now, and that's why we still have that to-do item to go consider the capability, that the way 7606 is defined, that we could enable the BGP OAD session on one side if attributes that are not needed would be sent, they would be ignored. In other words, standard eBGP would apply for the receiving end, and the session would remain operational. So I just want to say this again, and that's why I'm going to show the next slide. One of the action items or the to-do list that we have here is to go consider the potential advantages of having a capability to negotiate the peering type. And among one of them may be avoiding some extra errors in there. So This is, as I promised, the to-do list. We almost are almost done with the enumeration of the attributes. Of all the attributes, we're missing some like origin. And we probably want to go look at the container that is used for white communities, just because that is already outside of the working group, right? It's with the ASG somewhere. So we want to go look at those and finish enumerating those. Please go take a look at the list we have right now and provide comments on those, on what the behavior is or what we're proposing is going to be. And again, most of the behaviors there are going to be optionally. You may send non-transitive attributes across the eBGP OAD session. We need to, the other item on the to-do list is consider new role definitions. Currently, the draft says that the use of the roles defined in 9234 are not recommended for the eBGP OAD type. Again, something we need to go address and think more in our biweekly meetings that we have. We need to go talk about configuration and what may be configuration requirements that we have. Someone mentioned on the list that maybe we want to have a list of other OAD ASs in the vicinity, for example. Now, the draft talks about the definition of one session. There are some use cases that we're looking at where this would be used, say, with a stub AS, because there's a special business relationship there, and we would want to just have it there, for example. But it is obvious that we could, an operator could use eBGP OAD sessions to connect all their ASs, for example. So one thing that we are considering also is, what is the effect of that to the place where we have only eBGP session, from that place to the place where we have all eBGP OAD sessions, for example. If the default is of eBGP OAD is eBGP, well, what happens is we, through policy, start allowing things through. We are thinking right now that this would be a separate draft, meaning this draft, the current one, would talk about the session type itself. And then another one will talk about, well, what happens when you use it in specific ways. Not just everywhere to connect all your ASs, for example, migration considerations and things like that, but also other things that came up around, for example, exchange points or route server operation. So that may be an operational consideration type thing that we put into a separate draft. There is a draft that was pointed out on the list that we need to go think a little bit more and add some text around interoperation between OAD and the IETF-IDR-20230424-1400 attribute announcement draft. And we need to add text on what we expect to happen with new attributes going forward. In other words, we are listing the current existing attributes and the behavior that is expected from there in this draft. But the intent is for this draft to say, for future attributes, non-transitive future attributes, they would still optionally apply to the eBGP OAD session type. In other words, by policy, an operator can allow those non-transitive attributes to be announced to eBGP OAD peers. And so that way we won't have to come back and update this draft all the time. And if there is any exception, of course, any future attributes must indicate what any deviation is. And there was the other point about disjoint ASs. There were a couple of people who were talking about what happens when my OAD ASs are separated by someone else's AS. Well, that's out of scope for this, right? Because the continuity wouldn't be there. So we declared that out of scope. So what we're looking at is we are, as I just said, in the process of addressing all the comments that came from draft 00. We would love for you to go and read the current version of the draft, look at the diffs if you already looked at 00, and provide some more comments and more feedback. We, of course, eventually would like to ask for adoption. I think until we address the 00 comments, we won't be there yet. So it'll take at least one other round trip before we're ready for working group adoption. So that's it for this presentation. If anyone has comments, I've seen some things go back by the chat. I'm not sure if it's related to this or not. But in any case, comments, questions, please. So I see Claudio on the queue. If you want to go ahead.
I want to warn you, Claudia, that we're going to only take BGP-OID comments right now. I'll try to fit the send hold timer comments at the end of the session. So are you working with the OAM comments, Claudio?
Yes,
Oh,
I
oh,
wanted
please
to
go
say
ahead.
I think it's a good idea to use BGP roles for this to make sure that both sides agree with the type of the session. That's the only thing I wanted to say.
Great, thanks. Yes, said we're looking into that. Both from the existing roles point of view to maybe potential new roles. So thanks.
Any other comments? Alvaro, you might look at the original ISO version of BGP 10757 for that confederation concept. I think you're sharing some of the same things. I'll send specifics. Randy,
yes,
your turn.
Thank you. We didn't want to use the C word, but yes.
Yeah, I know. But Randy, your turn.
Alvaro, I would like some text that reassures me that I cannot signal you to leak things which are ill-advised from a security point of view.
Like
words,
what do you have in mind?
I don't want in my AS, I don't want you, an eBGP peer, to be able to signal to get my internal data, like local pref was your example.
Okay.
I believe I've actually cheated and read the draft. I believe that won't happen, but I think some security text is useful.
Sure, yeah, I see what you mean. Yes, we're not changing the behavior of eBGP session. But yes, I see what you mean, that you could end up with the wrong negotiation or something and prompt you to send something that you didn't want to send. Yeah, thanks.
Yep. And yes, ISO 10747 is the right number. Okay. Any more comments for Alvaro?
Great. Thank you, everyone.
Appreciate the comments. Our next speaker is Zentan. Let me pull up your presentation.
Thank you. Good morning and good evening, everyone. My name is Han Zhen from Huawei Technology. I'm going to give a presentation about a flowback redirect load balancing group community. Next slide, please.
Nope, I'm going to give you the control for the slides. You let me know if you can see the ribbon at the bottom.
Oh, yes, I can see that.
All yours. Thank you.
Okay. So this is the second time this draft was presented on IETF. So the last time was IETF 113. So it's been a year. I'm going to do a recapitulation about the motivation and problem segment. Also, we made a few updates and added some chapters to the draft after the last presentation. I didn't see the third slide. Do you see the third slide? Hello?
The third slide, I see motivation and problem statement. Is that where you're trying to go now?
Oh, yes, I did. Yeah, now I see it.
Okay. You may
So,
have some delay.
Okay. So as we all know, a BGP flow specification allows flow road that carries traffic policies to steer traffic. It's always been used everywhere. So in some scenarios, we may want to steer traffic to a load balancing group, either ECMP or UCMP. So as shown in the graph, we might want to do a traffic steering at R1 to R2, R3, R4 in a ratio, like 1 to 2 to 2. The ratio could be changing according to network running status. So for now, we have a redirect IP extended community, IPv6 extended community, and we can steer traffic to SRv6 terminal with a color extended community. So, but in some implementations, we can do ECMP of redirect to IP actions by encoding multiple redirect extended communities. But the current set of communities can hardly support either ECMP of SRv6 terminals nor UCMP of either types. So that's why we want to do a new technique. So we introduced the redirect load balancing group community. It's an extension to BGP community container attribute. So it's a new type of wide community. So the format of the wide community complies with the definition in a wide community draft. Besides that, it must contain only one parameter TRV. Within the parameter TRV, we have a list of sub-TRVs. Each represent redirection actions. So since last time, we made several updates based on the comments. Firstly, we rephrasing on the atoms. So now we call them sub-TRVs for redirection actions, because calling them atoms could be confusing with the atoms definition of the wide community itself. Also, we add some chapters about interactions with other redirection actions. So what we're suggesting is to do a configuration control. So the original extended community actions may take precedence by default. After you made some configuration on the device, the redirect group community take precedence. Also, we add validation procedures to the draft. So each pass TRVs of within the wide community, within the redirect group community, need to be validated separately, and the redirect group is considered verified only after all pass TRVs are verified. The verification procedure for each one redirect to IP follows the normal validation procedure of that. Also, we're thinking about the compatibility with FlowSpec version 2. But this mechanisms was mainly designed for FlowSpec version 1 scenarios. It does not conflict with FlowSpec version 2 action wide community. Oh, sorry, I forget to move the slides. And that's it. Thank you. And more comments and discussions are welcomed. I'm gonna put it one slide back because I forget to show this one. Sorry.
Go ahead, Jeff.
So I think for your FlowSpec v2 considerations, I don't think that's really well discussed at this point in time. Much like what we have for FlowSpec v1 and all the other action communities that we have defined currently, the main considerations are how do they interact with each other, especially if you stack more than one. This is just another addition to it. So I don't think this specific proposal changes too much from FlowSpec v1 to v2 at this point in time.
Yes, within the interactions with other redirection actions, we all we talk about is interactions with mechanisms that already exist in FlowSpec v1. We didn't talk much about interactions with FlowSpec v2 in this draft. So doing that, we may want to add some new sections later, or proposing another draft to talk about use of this in FlowSpec v2.
I would recommend putting the interactions with the FlowSpec v2 in this draft if that's all that you're missing. Please look at the actions that are in FlowSpec v2 and let us know. I think that would be better. And I should say that as a working group participant and not the chair.
Okay, thank you for your comment.
Do you want to make an additional comment? Or should I go on?
Sorry, please continue. I'm just having trouble managing my buttons a moment.
Okay, that's fine. I'm going to then go on unless there's any other comments on this FlowSpec. We're going to go on to a second FlowSpec presentation. Hang your next. Give me a moment while I load up the slides. Just a minute. There. Do I have the right slide set up, Han? You have control of the slides. It will be on the bottom.
Yeah. Okay. Hello, everyone. My name is Hang Shi. I'm from Huawei. And I will talk about the two drafts. Actually, they are all related to the CATS, Computing Aware Traffic Theory. I'm going to talk about the background and the extension of BGP-LS, and Xinxin Yi will talk about the extension to BGP FlowSpec. Yeah. First, I will introduce the background on the CATS. The CATS is a new working group on the routing area. It's chartered to consider the problem of how the network edge can steer traffic between clients and the service. The scenario is that one service can deploy multiple service instances in different sites, and the ingress router can route the client request to the suitable site based on their computing status. For example, their computing node or computing latency. In order to do that, the ingress needs to know the computing metric of each site to do the traffic steering. And this working group is limited to the overlay model. That is, the ingress router and the egress router will run on top of a tunnel, so that the computing metric will not affect the underlay routing. It's kind of like a VPN routing. Actually, we have an existing method to pass this computing metric. It's in the IDR working group. It's called the service metadata. This service metadata defines a set of computing metric can pass using the BGP. It's a new pass attribute. And if we are running BGP between the site and the egress router and the BGP between the ingress and the egress, for example, this R1 and R3, in this case, the computing metric of the site can be passed to the R1, the ingress router. And combined with the terminal information, this R1 can generate the final computing wire route to steer the traffic to the appropriate site. But we are proposing a new solution that we do not want to touch the BGP between the ingress router and the egress router. So we can use the controller to do some kind of relay the computing metric. And for the controller to connect the computing metric from egress router, we use BGP-RS. And for it to distribute the computing metric, we extend the BGP flow spec. The basic assumption of this scenario is that we still use the BGP to pass the computing metric outside of the computing site. For example, in this picture, the BGP is running between the R3 and the site 3. So our first extension is to the BGP-RS to collect the computing metric from the egress router to the controller. Basically, we are reusing the edge service metadata draft. We reuse the computing metric defined in this draft. For example, we have site preference and the capacity index and the node measurement and pass it using the BGP-RS. And we also add a corner attribute TRV. This corner is just like the route corner, the network corner, to indicate the service level. The different service instances may have different price, for example. And we reuse the prefix NRI and the prefix seed attribute for this extension. And yeah.
Hello.
You can
Hello.
go ahead.
Okay. Hello, everyone. I am Yixinxin from China Unicom. For the next few minutes, I will explain the distribution of computing metric. We proposed an extension of BGP flow spec to distribute computing metric. In the figure 1 shows the distribution diagram of service data using BGP flow spec extension. Add a service metadata to the flow spec routing policy data sent by the BGP flow spec controller to the entry node to describe the calculation metrics. The computing metric can be described in two ways. The first method is to refer to the original metadata path attributed in the draft name is the BGP extension for 5G edge service metadata. The second method aggregates some calculation attributes and describes them by numerical values. This is the description format. Requirements for calculating metrics by aggregation are shown in figure 2. Include aggregate metadata type, length, and value. That's all for my introduction on the BGP flow spec extension. Thank you.
Hung, are you done with your presentation?
Yeah, I'm done with my presentation. This is the GitHub link. Anyone can file an issue or PR if they have any questions.
Okay. Is there any additional questions for Hung? Okay, we're gonna then go to Yijing, and if I pronounce that right, I'll go put the presentation up for that. Just a minute. Eugene, did you complete yours? You did this in the same piece, so there's, just a minute, I think I've got the wrong slide set. My apologies.
I just explain.
Was the slides were contained in the same slide set, so you went ahead and presented that. Is that correct, Eugene?
To explain it, so I don't want to.
Okay, just a minute.
Yes.
Give me one moment, folks. Take a mental break while I try to find the right one.
Sue, she confirms that the presentation that was just given contains Shinshin's.
Good. That's what I just said. And Shijin, did you have anything? Did anyone have any questions for Shijin? Okay, then we will go on with Ran's presentation. Has Ran appeared yet today? There you are, Ran. I'm going to give you the slide set. Thank you for your patience.
Thank you. Hi everyone, I'm Zan. Today I would like to do the presentation about SR policies extensions for NRP in BPLS. And sorry. Yeah, this is the introductions. Segment routing policies are all this list of segments that represent source-routed policies. And IETF network slices introduced the concept network NRP, which is a subset of the resources and associated policies in the underlying network. And draft-down IDR SR policy NRP defines the extensions to BGP SR policy to specify the NRP which the SR policy connected path is associated with. In this document, we defined a new TLV which enables the hand aid to report the configuration and the state of the NRP which the SR policy candidate path is associated with. This is the BGPLS SR policy extensions for NRP. In this document, we defined a new SR policy state TLV. We called it NRP TLV to carry the NRP with the SR policy content path is associated with. The NRP this is the format of the NRP TLV. The NRP ID is is a global identifier of network resource partitions. This is the procedures. SR policy candidate path may be instantiated with a specific NRP on the hand-aid node via a local configuration PCEP or BGP SR policy signaling. Then the state and the attribute of the NRP, the candidate path of SR policy is associated with is encoded in the BGPLS attribute field as SR policy state TLV. The SR policy state TLV, which is defined in draft IDR BGPLS as policy, are not changed. It can be used to report the SR policy candidate path, state, and attributes. And the NRPTLV, which is defined in our draft, is included to report the state of the NRP. So next step, comments welcome. Thank you.
Hi, good morning and good evening again. It's me again, Tanjun from Huawei Technologies. This presentation is about road target constraints for BGP flow and BGP ISR policies. This draft is an informational draft, so it does not propose any new piece of technologies. It's just a combination of existing mechanisms. So during the distribution of SR policies or flow spec roads, so there's usually a controller used to distribute this. So if the controller send a flow spec road and or a SR policy to an RR, the RR need to reflect the roads to all peers. And the client will apply an ingress road policy, either static or dynamic, to filter those roads and to keep the road at target zone. This procedure may cause a waste of bandwidth and network congestion. By exchanging BGP road targeted roads, a BGP speaker could generate egress policies for filtering one or a group of network nodes. So just work as a flow spec ORF or as a policy ORF. Let's see this example in the graph. So if the PE1 and PE2 send this road target membership NRI with its AS number and a router ID to RR through the road target NRI. After receiving the update message, the RR will trigger the reroutes of the flow spec roads to match the egress policies with a road target extend community on the road and updates those roads to the PEs. So instead of using the ingress policies on the PE, we propose to use the egress policy on the RR. If multiple layers of R are deployed, the R need to advertise all received road target membership NRIs to the upper layer R. So the proposed format of the road membership NRI is defined like this. So we're using a IPv4 address specific extended community as a road target. The subtype is gonna be 2 road target, and the global administrator is set to 0, and the local administrator. The global administrator is a road identifier, which usually be the router ID for the for BGP router, and the local administrator is reserved for future use. I mean, it must be set to 0 up on the sender and must be ignored up on the receiver. That's basically it. Thank you. Oh, I'm sorry, I forgot to show the slides again. It's my first time to control the slides on my own. Since I still have time, I'm gonna reading this. So so this is the proposed format of the road target membership in NRI. So we're gonna use a IPv4 address specific extended communities as the road target. So the subtype is 002 for road target, and the global administrator is a road identifier of the node. Usually it's a road ID for BGP router, and the local administrator are gonna be reserved for future use and must be set to 0 for now. Thank you. Any questions?
Yes, I appear to be in the queue. Would you return to slide 2, please?
Okay.
So my question here is pretty straightforward. I understand you want to apply, to SR policy routes and flow spec, RT constraint. That's very straightforward. I don't understand what flow spec ORF is here.
Oh, so for using these techniques, the flow spec will need to carry an RT extended community on the road to match with the RDC road.
Okay, so your terminology is you're trying to call a flow spec ORF route this combination.
Oh, I mean the flow spec road need to carries an road target extended community to in order to use this mechanism.
Right, but outbound route filters are router to router and do not get carried across routers.
It's just controller to router.
Okay, I guess I need to read the specification in more detail. I also placed into chat a link to Jidong's node target community. I think you may find this might be a better fit than a standard route target.
Oh yes, I talked with him. We're colleagues. So I talked. This mechanism could also use with a node target community. Yeah.
Okay, thank you. Those are my questions.
Okay. Any other questions for Zen? Okay, thank you very much, Zen. I'm going to allow, in case we want to get back to comments that we had on the send timer, would anyone like to provide additional comments? Claudio, you had questions, and I believe Anchor's still here. Or so, are there any further questions or comments on the send hold timer or Anchor's draft? We will add it now. Go ahead, Claudio.
To say before was that in a way the two drafts are kind of doing the same thing, and what we could do is like the important thing is we want to actually detect this, and how it's implemented is kind of open for people for the individual implementation. And I think there should be an agreement that like both drafts are working, like it's the technical implementation, and I think either solution would actually work. And for OpenBGP, the version that I did, I'm actually quite happy with the implementation we have, and it seems to work very reliable at detecting this situation.
Any comments for Claudio? Anchor, go ahead.
Comments, Claudia. I think earlier you mentioned that basically you have some specific cases that basically the TCP user time would not work, but the BGP timer would work. I would like to basically see the look at more detail. Yeah, if you can share that either privately on the mailing list, that would be great. Second comment is about the OpenBGP implementation. Is it correct that what the job is showing on the slides is about the OpenBGP implementation? With basically multiple if statements that at these conditions it would work. Basically, local TCP buffer will be full. Is that the OpenBGP implementation?
Yes, it's more or less
Okay.
how it works.
Yeah.
Yes, it's
So
a bit high
in that
level.
case, I think, yeah, that's what I like to point out. I think I pointed out earlier, basically with that if statement, basically it's a it's a subset of the problems. I think for you guys to point it out, because if there's a important PGP update, the message that's stuck in the local TCP buffer, and buffer is not full. It's not being delivered for extended period of time. It's the same damage. So that's why I would call it as a partial solution. Yeah.
For us, the big thing is that the BSD network stacks don't implement the TCP user get opt. So for us, this is currently the better,
so either basically
better solution.
Yeah, you know, it's a timer coding of timer is pretty straightforward, as I point out. So it's probably does not require that much code to just add the TCP user timer into the stack.
It's more code than implementing the user, the send hold timer in BGPD.
Yeah. So as I say, you know, it's basically it's you know, TCP user timer would be more complete for that issue, because whether the local buffer TCP buffer is full or not, as long as the data is stuck, it's not delivered for extended period of time, the TCP user timer would kick in. So it's a more complete solution. That's what I like to point out.
It's an equivalent solution.
No, it's I keep repeating myself. It's solve the BGP solutions solve some cases, but it's incomplete. I would not characterize them as equivalent, because they are not.
Yeah. What does your solution cover that the other one is not?
Yeah, basically what I'm saying that the TCP user timer does not care whether the local TCP buffer is full or not, as long as the packet is not delivered on time or not delivered for extended period of time. That that TCP user time will time out. But in the BGP-based solution, because yeah, there's not much you can do. You don't have visibility into TCP buffer. So that's you basically, what do? You say basically, if the local TCP buffer is full, yes, you can. It helps. That's but it's a subset of the problem. So there are differences, but yes, in some cases, you know, it would work, but for other cases, the BGP-based solution will not. Yeah.
I think in the end we're just splitting hairs over something that doesn't really change the aspect of the overall solution of detecting stuck routes and detecting stuck sessions.
It sounds like you both have some good discussion with one another that you might take offline and come back and report to us to the working group via email. Is there anyone else that would like to chat about the BGP timers? Any other comments for today's interim? Jeff, Kayer, any comments before we close?
No comments for me, although I'll repeat this on the mailing list. The missing details that people seem to be talking past each other and the send hold timer and the TCP user timeout values. Send hold timer is fundamentally about blocked sockets, which can happen in some implementations, even for non-zero windowed environments. Basically, if you have a big enough update and you're trying to send an entire update and it can't fit in the window, that can manifest in some implementations that way. And for the user timeout piece, the requirement is that you don't get an acknowledgement. The things the send hold time, the TCP timeout authors don't seem to be getting is zero windowing can happen, and you're still getting acknowledgements back. You're just getting acknowledgements back that have nothing in them. It's telling you the zero window is still there, but you've received acknowledgement within the time frame.
Hi, Jeff. I think you are probably talking about the Linux, that implementation bug, which has already been fixed.
I am talking about RFC 793. If you look under RFC 793, under reliability, it says if the ACK is not received within a timeout interval, the data is retransmitted. The ACK is coming back. You're sending a packet. You're still sending your keep alives. You're getting ACKs back. That says that the receivers may have not advanced your window. You may get it. You may continue getting ACKs back. That just keeps to tell you the zero windows there, and eventually you're still acknowledging their frames, but they won't eat yours. X are still flowing.
Okay, I think Jeff. I think let's exchange privately. I like to understand the specific cases to see, because
this will be a repeat of the stuff on the mailing list. I'm happy to copy and paste the original threads.
Yes, please. Yes, please. Or you point out to me through the link. I will need to think about this. Yeah. Thank you.
That's it. That's it for me, Sue.
Okay. Care, anything that you'd like to mention? Here in the chat window someplace.
All good from my end.
Oh, good. Great. I'm glad the auto worked. Well, folks, then I think we're going to return 15 minutes of your day back to you. Thank you very much, and we will close the session now.
Everyone.